Hello, in this video we will examine how students can use ClassWiz to solve equations and support their understanding of equations. There are several ways of using ClassWiz to deal with equations. One way is to use a table of values to get an approximate solution directly. So let's look at an equation like this one. X cubed subtract x is equal to 1. To solve this equation, we need to find the values of x for which x cubed subtract x subtract 1 is equal to 0. And one way to do this is to tabulate a suitable function and find the values of x, if any, for which the value is 0. So we've turned our ClassWiz on. We need to select table mode, which is menu, and if we go down, it's number 9, and enter the function x cubed subtract x subtract 1. It's a little bit different from the equation, but we're looking to find the value of the function being equal to 0. We'll tabulate this function over a wide range. Let's say from negative 15 to 14 in steps of 1, remembering that the ClassWiz allows us to have only 30 values in a table. When we scroll the values in the table, we can see there are very large negative numbers there, decreasing down to something close to 0 there, and then they're getting bigger again. And it looks, if we look carefully, somewhere between 1 and 2. When x is 1 and x is 2, there's a value when the function might be 0. So let's look more closely at the table for those particular values, near those particular values. So clear. We'll change the values now to those between 1 and 2 and use steps of 0.1 to look in a little bit more closely. Now the values of the function we can see are negative there, and all of a sudden it's positive. So it seems as if the values of the function change from negative in 1.3 to positive when x is 1.4. So we can make a fresh table between those two values of 1.3 and 1.4. And again, it's the same routine. Press clear, equals a couple of times. 1.3 is the minimum value, 1.4 the maximum value, and we choose a smaller step so we get a more refined table. And here we see 1.3 is negative there. Now it's moved to positive between 1.32. When x is 1.32, the value is negative. When x is 1.33, the value is positive. And so we need to, again, get another solution somewhere between 1.32 and 1.33. So let's go back and do that one more time, just to illustrate the idea. 1.32 and 1.33. And a small step of 0.001 this time, and we can get pretty good approximation by such a process. We can see that when x is equal to 1.324, the value is negative, and when x is equal to 1.325, the value is positive. So there is a root of the function somewhere between these two values. It's also possible to get closer approximation by changing the x values directly. So we could, for example, change 1.325 or 1.324. Let's change it into 1.3245, and the value of the function changes immediately. We can see that it's still negative. Maybe we'll try a slightly larger value. And oops. And we see that in fact it's still negative, but we can continue in those ways and see certainly that the one of the solutions to the equation for 3 decimal places is 1.325 to the 3rd decimal place. Processes of this kind are sometimes described as trial and error, but I think a better description is guess, check and improve, as thoughtful use of the calculator is required. We make a guess, we check it, and we improve it. Notice the idea of the equation is being considered constantly. What's the value of the function? Is it equal to 0? Another example, but with a different solution method, involves solving, let's look at this equation here. 2 to the power x is equal to 7. So if we change to calculate mode, menu and number 1, you can see it's called calculate mode, we could make a guess. What power of 2 is equal to 7? Well, we'd think 2 to the power 3 is too large, because that's 8. So let's choose something a little bit less than 3. 2 to the power, let's say 2.9. Is that equal to 7? No, it's a little bit too large. So let's improve the guess, and I'm going to use the left cursor key here and edit that value and change it to something a little bit less, maybe 2.8. No, that's a little bit too small. So now we need to choose a value that's larger than 2.8 and less than 2.9. It's only a little bit too small. Let's try 2.81. And that's a little bit too large. So we can improve the guess again by choosing another value. Each time I'm moving the cursor up here, changing the value. Let's say this one, 2.805. That's a little bit too small. You can see the idea. This sort of process can be quite efficient for some equations and is reinforcing both the idea of the equation and also the sizes of the numbers. In this case, of course, a good approximation is available directly using a logarithm function to the base 2. And on ClassWiz, logarithm to the base 2 of 7 tells us what power of 2 is equal to 7. And the result is, as we saw, 2.807. We got quite close to that just by approximation procedures. So, in addition to procedures of these kinds, ClassWiz has some automatic commands for solving equations numerically. These can be useful to avoid excessive time being spent on routine manipulations and allowing more time for students in class to spend on formulating equations. So let's look at these briefly. Some of them are in the equations mode, so we need to tap menu and find equation. You can see the symbol there, the symbol for an equation with an equal sign. The name is equation/function, and we just can press the equals key here and see here we have a choice of simultaneous linear equations or polynomial equations. So let's look at a pair of simultaneous linear equations. So to do that, we'll tap number 1, and there are 2 unknowns in this case, so tap number 2. And you can see that ClassWiz expects the equations to be entered with the x term, then the y term, then the constant term. So for the first of our 2 equations, x is 2, so that's okay, and tap the equals key. Y is 7, that's okay, and the constant term is 5, that's all right. The second equation, however, the equation is written in a different form. 2y is equal to 3x, add 4. So to enter the coefficients here, we have to reimagine the equation as negative 3x, and students have to learn to do this in their head. Negative 3x, add 2y, so y is equal to 2, and the constant in that case is 4. So you can see the equations entered up here look a little bit different from the equations down here, but we've entered them in the way that ClassWiz demands. The first value was negative 18 on 25. The students would have written these values down. We will store that by tapping the store key into memory X, and the other value was 23 on 25, and we will store that into memory Y. So now we have a value for X and a value for Y, and we can check that the equation is correct. 2x add 7y, have to have alpha, should equal 5, and it does for those 2 values of x and y. And secondly, 2 times y, the value is 46 over 25, should be the same as 3x add 4, which it is. So the class whiz can be used to check the solutions to the equation as well as to find the solutions in the first case. Normally students wouldn't do that because it's too complicated. Okay, let's go back to equation mode, menu and A, and this time we'll look at a polynomial equation. Let's look at this equation here. X squared add 5x is equal to 3. So polynomial equation of this kind is of order 2. So we have to select the degree of 2 and now enter the coefficients in the correct way. Notice that the way class whiz expects the x squared is first, then the coefficient of x, and then the constant. So our equation is written a little differently. So the three values are 1 for A and 5 for B. That's not a problem, but we need to make sure that the value for C is negative 3 because that's the form in which class whiz expects the results. So once we've entered the equation in the correct way, tap equals to get a solution. There's one of the solutions, and if you wanted a decimal approximation, the S to D key will give a decimal version of that, although that's the exact solution, and then tap equals to obtain the other solution. Notice that if you tap equals a further 2 times, you'll obtain the coordinates of the turning point of the parabola. So the minimum value of the parabola is, in this case, is when x is equal to negative 5 over 2, and the actual value of the function concerned with this equation is negative 37 over 4. This is really helpful to graph the parabola that's associated with this equation, because the roots of the parabola, which are the solutions to the equation, and the turning point are all determined automatically. If you tap equals, the equation will reappear again, and you can edit it or change it to a different equation for some purpose. Finally, some equations are neither linear nor polynomial, but you can still use class whiz to get good approximations for solutions to them. So let's consider this equation here. 3 to the power x is equal to x add 4. We could find an approximate solution using a table of values and a suitable function, as we did earlier for the cubic equation, by rearranging it and finding out when the values were equal to 0. But there are other methods as well. So let's use another method using the solver on class whiz. To get to that, tap menu and number 1 to be in calculate mode. And now write the equation exactly as it's written on the screen here. 3 to the power x, and move the cursor to the right so it's no longer in the exponent. Now we need an equals key for the equation. Don't use this one down here. There's another equals key up here using the alpha button. Alpha, and then the calc command will give us equals, and then x add 4, which is the rest of the equation. So here's our equation. And to solve the equation, we're going to use a solve command to give us a numerical solution. Here's the solve command over here. Tap shift and solve. And the class whiz shows the present value of x. That might or might not be a solution, but we have to make a guess. What's a guess for this equation? So if we think about it, 3 to the power 2 is about 9, 2 add 4 is about 6, so it's around about there somewhere. Your guess doesn't have to be too close, but class whiz needs a start. So let's try 2 and press equals. The class whiz shows that it's understood. 2 is the first guess. And now if we tap equals again, we'll have a numerical solution. And notice what the class whiz shows. When x has this value, 1.5619, etc., then the left side subtract the right side of the equation is equal to 0. That's the idea of an equation. The left side and the right side are in balance. So the solution, while it isn't exact, is quite accurate. Now there might be some further solutions. So students need to think about the equation and think about its form, think about the components of the equation. Could 3 to the x be equal to x add 4 anywhere else? And if you think about the function and think about the graphs of the function, which is a good way to think about these things, like so. The line y is equal to x add 4 is the red one. The exponential function is the blue one. It looks like there's another solution somewhere to the left of the origin. Looks close to -4, but we'll put in tap equals, we'll put in a guess that's somewhere near there. And to show you that it doesn't have to be too close, let's think about, say, -10 as a guess. And the graph, if you've drawn a graph and sketched a graph, it's clearly not very close to that, but it's close enough. So now tap equals, and you can see the function comes up with -3.987 as the value for x, and once again the left side and the right side are equal to 0. So this particular equation has two solutions, and students can reason that there probably aren't any other solutions because of the shape of the function and understanding the shape of the function that's involved. So the class whiz is supporting their thinking, and as you can see is a powerful tool for exploring equations of various kinds. This video has shown some ways of using the class whiz to find approximate solutions to equations. We use some guess, check and improve methods, and we use some automatic procedures. You'll find that Module 4 of the Learning Mathematics with the Class Whiz book contains further information on how to work with equations on Class Whiz, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check efficient Class Whiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!